So yeah, thanks very much for coming tonight. So if we're all in the right place, right, we're going to be talking about the AI functionality that's gone into Power BI. So we're going to take that from a kind of my approach. So by no means like looking at lots of DAX and stuff. That's not me. I'm not that guy. I'm not like you show me DAX and I'm like, yeah, cool, that stuff. I'm sure it works. It looks very good. But that is not me, right? I am very much on the other side. I'm very much specialised in machine learning and other elements. But things like that, give me DAX, that's not my problem. So don't ask me those questions, but anything else, and we're all good to go. So I run a company in the UK with Mr. Simon Whiteley, who's just there, called Advancing Analytics. We specialise in pretty much anything to do with advanced analytics, and particularly on the Microsoft platforms. That could be data engineering, that could be machine learning, and basically a lot of the stuff in between. So we've got stickers, a variety of different things over there, general kind of stuff that we take with us. I would also call your attention to the Data Science and Production podcast that we have that we infrequently update, but it's available there for you to listen to. And that really focuses on some of the core fundamental problems that partly what we're talking about today kind of helps a little bit with, which is that people who build machine learning models typically suffer massively when it actually comes to productionizing them and trying to get any kind of return on investment, right? So that's what that tries to help you solve, and you can listen to it on your drive home, etc. Some more stuff about us, or a gold partner, etc. Right, so any questions, by all means, stop me, shout them out, keep them to the end if you want to. I'm easy either way, right? So what are we going to do today? We're typically going to do a couple of things, right? So we're going to take a critical look, okay, at some of the way that AI has been implemented into Power BI and try and talk a little bit around some of how the models work and what you need to think about if you're going to just kind of go next through a lot of these kind of options, right? We're going to explore if Power BI enables the kind of Gartner idea of the citizen data scientist. And ultimately what we're going to do is look at creating a variety of different models, look at a couple of different approaches that are in here. And also we're going to look at a lot around kind of AutoML and the way that that can help democratize machine learning, right? Okay, so machine learning. All right, this is a nice kind of stuffy definition, right? So machine learning provides a system the ability to automatically learn and improve from experience without being explicitly programmed. Now the reason we call some of these things out is because they're quite important, right? We're looking to try and do something without explicitly programming. If you look back to the kind of 80s, early 90s, where expert systems were really popular, expert systems are heralded as this kind of true AI, and everyone kind of saw that kind of way of working ultimately as Skynet and the rise of the machines, right? And they were just basically huge knowledge-based systems, and somebody would be like, well, if this happens, then this happens, and this happens, and this happens. These huge monolith systems, okay? So they were explicitly programmed. So we're looking to do a kind of similar thing, right? But without being explicitly programmed. So it relies on this underlying hypothesis of creating a model that tries to improve, and we try to improve it essentially by fitting it with more data over time. And the reason we call out some of these terms is because these are other terms that we use very frequently, things like fitting, things like improving. As we go through and talk about some of these stuff, you'll start potentially seeing a couple of terms that you may not be familiar with, and as a data scientist and data science community, we change the way that things are said because we want to alienate people from our industry so no one comes and play with us, right? So yeah. So if that definition has kind of left you like, I don't know what's going on, like don't worry, right? Because kind of the whole crux of what we're looking at here is essentially machine learning is being democratized. If you look at the kind of trend, at least in the last 5 or 6 years, at how machine learning has improved, there's been a massive amount of kind of taking the stuff that is becoming quite trivial and then making it even more trivial by basically firing lots of compute at it, okay? The hard stuff is still hard. Things like deep learning, etc., they're still hard. But a lot of the kind of grunt that we went through a couple of years ago has really, realistically, been automated away to some extent, all right? And we'll have a look at it, okay? So a lot of it is being democratized. So let's talk a little bit about the machine learning process, okay? So this comes from an article a good few years ago now from a Google Cloud Advocate, and there's a link at the end, which talks about the machine learning process, okay? And what the machine learning process really does is a little bit like this, right? So we go and we gather some data, yeah? We're all probably familiar with that. We gather some data, then we start preparing that data. We visualize it, we try to understand it, we go through a phase which is typically known as EDA, Exploratory Data Analysis. Because ultimately what we're trying to do with any kind of machine learning model or any model that we build is we're trying to essentially create something that's going to generalize to the problem we're trying to solve. So if there's lots of nuance in there and there's lots of kind of like awkward kind of bias in there, it's those kind of things that through that EDA phase we need to engineer out, okay? That's what that's kind of doing. Then we typically select an algorithm, something we're trying to do, right? We're trying to predict something, we're trying to understand it, we're trying to forecast something. We select an appropriate algorithm, and these are very generic algorithms which are designed to kind of work with lots of different problems. Essentially what we do then is we take our data, we take that model, we just kind of like mush these things together, all right? Essentially what we're doing is we're tweaking a whole load of parameters inside this generic model by doing a lot of kind of linear algebra in there, which ultimately will try to fit that model, right, to what we're trying to generalize and trying to predict, okay? Then we evaluate it, try to work out, you know, have I got a good model? What is a good model, you know? Is it one that predicts well? How do I understand it? How do I interpret whether or not I have a good model? And lots of this stuff is super important, okay? Understanding whether or not you have a good model is crucial to what we're trying to do, yeah? Then when we're happy with our model, we typically go to a phase of hyperparameter tuning. That is where I'm basically trying to squeeze as much additional performance out of that model as much as I can, right? So I look at trying to do things. I try to remove any additional bias, try and get the best out of my model as possible. I test it, I give it new data, etc., and hopefully we've got something good. So this is the 7 steps of machine learning. This is what people talk about a lot. Basically pick up any book on machine learning and they'll talk you through some kind of variation of this. The key one that they always miss, every book seems to miss it, is always about how we actually go about deploying something, right? How do we get something in production? How do we get some kind of return on investment on what we are trying to do? Because data science teams, they're not really that cheap, right? They're quite an expensive resource. And if they're not used well enough, then they're typically very expensive and a large cost, right? So let's talk about a couple of different examples, some that we'll look at in Power BI, okay? So my mustachy friend, my mustachy friend says, hey, I'm trying to better understand my customers, right? I think there might be a pattern in their behavior, but I'm just struggling to see it, okay? So, first thing that we start with is we're trying to kind of break down what he's trying to get to, right? It's a very common requirement. As running a consultancy, this is typically what we get involved in, yeah? People have problems, we look to try and help. So we're saying, right, I want to better understand the patterns and behaviors, right? So try to understand patterns and behaviors. What we're not trying to do here is we're not trying to really predict something, but I'm trying to find trends in my data, okay? So I typically take some data, and then I try plotting it in some way. So what I have here is one feature against another. So a feature here, we're just talking basically about an attribute in our data, a column in our data. It's just a fancy machine learning term for that, right? What we do is we start taking our data and we start plotting it, and then, if by magic, as if I planned this, right, we start seeing there's some kind of pattern appearing here, yeah? And this might be looking at the amount of time that somebody spends on our website compared to the amount of money they spend with us. Maybe we're looking at something like recency, frequency, intensity, which is a good way to gauge your kind of customer interaction. Maybe we're looking at something like that. And with our kind of experience as data professionals, we can start adding some kind of boundaries around this, yeah? And seeing, okay, well, where I kind of have this thing happening, then where my customers are here, they're at risk of like kind of leaving my service. Where they're here, they're good customers, but what I ultimately want to do is push them up and get the most amount of value out of them as possible, yeah? And where I see here, and I see people starting to trick down into this kind of thing, is where I need to intervene. Maybe I need to market to them, offer them some kind of promotions to get them to stay, yeah? This is an example of clustering. Have a look at 2 more examples. My mustachy friend is back. He says, hey, I'm trying to predict how much someone is going to spend with me next time they come into my store. So the key difference here between the last one and this one is that we have something we are trying to predict, and in this example it is spend. It's something which is numerical, okay? The numerical part is important. So again, I take my data and I take my features and I start plotting it, and then, again, there's something happening, right? These 2 features appear to be quite well correlated. And again, this is a very trivial example, yeah? We're taking 2 dimensions. Typically this stuff happens in multi-dimensional space, And ultimately it's kind of very hard to draw multi-dimensions without getting very confused, right? So here maybe we're looking at, again, the amount of time that somebody's with us, maybe spend, maybe we're looking to try and forecast something there. So what we typically do here is we plot some kind of line of best fit. That could be a linear line like this, where we're doing something basic like y equals mx plus c, where we're looking at basically where this line crosses over. And we've generalized to say when I see a feature up here, I go up and then I get this, right? Some kind of regression-based approach. So we'll look at how we can do a regression-based approach in Power BI in a moment. So my last example is I'm trying to predict if an insurance claim is fraudulent or not. Hands up, who commits fraud? Yeah, okay, there's always one or two. It's being recorded, I think, so we're all good, right? So fraud's really hard to predict, okay? Fraud is typically, hopefully, in your data, what's known as a class imbalance, okay? It's where you have a lot of data, and hopefully fraud is so minute in your data that it's very difficult to try and predict it in an approach that we'll look at here. So I can guarantee if you have fraud that is only in less than 1% of your cases, I can create you a 99% accurate model of predicting fraud for your organization. Like, wow, yeah? I just say everything's not fraud, okay? 99%, right? I'm good. Okay, so that kind of stuff we don't want to happen, yeah? And that can be some of the problems that we can start hitting on when we're looking at trying to do things in a kind of automated way or a simplistic way, okay? So, we're trying to predict if something is fraudulent or not. Here what we have is, we have some data again, and here I'm doing a classification. This example here is what's known as a binary classification, yeah? I've got something is true or something is false, something is 1 or 0, something is fraud or not fraud, okay? So there are different types of classifications. So this one is binary, you have multi-class, you have multi-label as well, depending on what you're trying to do. Is something A, B, or C? Is something a little bit of A, a little bit of B, and a little bit of C? It depends, and there are different variations, right? This is an example here of classification, okay? Cool. So, types of machine learning that we've seen, right? We've got clustering, we have regression, and we have classification. Now these are 3 examples of what are typically referred to as our kind of shallow machine learning approaches. There are the deep learning approaches, which we're not really going to talk about because they're a bit more complicated, and certainly there are aspects in Power BI that we can leverage. But really, when we're looking at things that need GPU training, etc., then Power BI is, today not the tool for that, right? So when we have these are, I say, 3 types of machine learning model, but there are more. We'll just have a quick focus at some of these. Now, typically, they are referred to as unsupervised and supervised. Now, that really comes down to, because on the last 2 examples, on our regression, our classification, we were optimizing for a label, right? It was either going to be spend or fraud. That was our label, that is our supervision. We are saying, when you train, right, optimize for this label, okay? So when it comes to looking at things in Power BI, we can very nicely kind of do these 2. Clustering, you could argue you could do, but out of the box, when we're looking at some of the AI functionality, today this stuff doesn't exist, right? So there are subsets and huge subsets of problems which don't quite work, but I'm sure over time that stuff will happen, right? But today we're going to look at some of these ones down here, regression and classification. So let's focus a little bit on what supervised learning is, how that works, and how we would typically tackle this if we weren't looking at something like Power BI, okay? So we take our data again, and typically what we're doing is we're looking to split our data into a training set and into a testing set. And the reason we do that is we want to train with some data, and that data is going to have our label, right? It's going to be optimizing for that label, and we want to hold back a section of our data that we've never showed to our model through our training phase so that we can validate with it, yeah? So what we can say is basically, well, where you expected it to be fraud, was it fraud or not? Where you expected some kind of regression value, how close were we, okay? So we take our data and we typically take some of it for training, and then what we do is we take that generic algorithm, we tweak it, yeah? And then we get a model out the back of it. And then we take our test data that we've held back, and then we show it to our model and we score it essentially with our model. So we pass our data through with our label that we're expecting, and then we just essentially compare the 2. So we evaluate it, we validate it, and make sure that it's sort of appropriate for what we're trying to do, okay? Then ultimately what we do is we take that model and we try to productionize it, yeah, and we show more, and hopefully it adds some kind of business value, hopefully it improves the way we work, yeah? Data goes through, label the point a little bit, and you get the idea, right? So that's what we would do typically if we weren't looking at a tool like Power BI, okay? So kind of what options are available if we're not looking at Power BI? So the general land that we play in, we typically refer to as our data science octopus, right? It's got 8 little arms there. And so typically, we're sort of playing up here, right? Things like Azure Machine Learning Services. Maybe we're looking to train a model, build that out, and typically a very nice kind of platform agnostic approach is to use Docker and Kubernetes so that we've got a nice load balance approach. And that all comes down to things like, where's your model being surfaced? Is it through a website? Is it through your kind of line of business applications? Or is it something that you want to do historically, where you're just looking at the data and looking at what has happened? Kind of traditional warehousing approach, then taking something like Docker and Scala and Kubernetes, etc., these kind of things in that picture, you just don't need, right? And that typically comes down to, we break this down into basically essentially interactive versus batch. So when we talk about looking at things like Power BI, we're very much in the batch way of working, but we are more down here, okay? We're more down in our kind of citizen data science. Now, I hate this term, okay? I really dislike this term. I think it takes a lot away from what these guys do, but it's a term that gets pushed very widely by Gartner, and unfortunately it's probably here to stay. So we are very much kind of focusing in this place, yeah? We are down there, we have Power BI, which appears to kind of be aimed at our citizen data scientists, yeah? So they are typically people who are very interested and engaged in machine learning, but may not come from a deep statistical background, may not have great experience in, say, something like Python or R, and probably not on the deep learning side as well, okay? Far more comfortable in a tool like Power BI or like Alteryx or some of these other ones that we saw in that picture, yeah? So I think Microsoft have kind of noticed this and really pushed a lot of AI functionality into Power BI. Essentially what we're going to look at now, right? So what stuff is there available? So if you have a look at AI in Power BI today, you can kind of break it down into like 3 different ways, okay? You've got the stuff which is very much focused at the end user, very much kind of focused at, right, I've been given a kind of model already, and I'm going to drag in some visuals, and I'm going to try and work with it, yeah? So we've got the kind of Q&A experience that's been available inside the portal for the last couple of years, which has now gone in very much into the Power BI desktop as well. We have the key influencer visual, and we have the decomposition tree as well. So we'll have a little look at some of those. We won't touch on them massively because although they're very much classified as kind of AI functionality, they definitely are not. They may have elements of AI in them, but they are certainly not AI in the traditional sense of machine learning in any way, shape or form. We would typically refer to them as just kind of advanced analytics, right? They are an advanced approach to analytics, but they are not AI. Then we move on to the kind of more focused around the Power BI developer, so somebody building a model out, right? Where we have text analytics. So we'll have a look at that. We'll have a look at how we could take some raw text data and do some kind of interesting things which have, again, been fairly trivialized and made very easy for us to use. So look at text analytics. You have things in here like the Vision API. Now the Vision API certainly is an approach to deep learning, but where it factors into Power BI, it's very much on the inference side, okay? Which is where I take a model that I've built through Cognitive Services and deploy it, and essentially I can give that to Power BI to do my inference, which is a great thing to do, but it is certainly not the training element. Then we have Azure Machine Learning, which essentially we do a whole variety of different things. That's the kind of nice GUI drag and drop interface that you have, exposed through Azure, plus being able to do a variety of different tasks in there, and actually port that stuff directly into the models that you have and enrich them, right? That stuff's pretty cool. The last one being there is more around that kind of data flow aspect, which is really looking at AutoML. So AutoML is where I want to focus as well a bit of time today and really have a good look at, because that's where you're potentially going to get a lot of value without having to know a great deal about what you're doing, okay? Right, so Power BI, the AI aspects, okay? So we have the key influencers dashboard, right? And the visual, where we are looking at, what has gone into potentially increasing, or what has led to a particular measure being important, yeah? So I believe it's still in preview. Again, I'm certainly no expert on this one. We're still in preview, but that gives you a kind of nice way, without really doing a great deal, to infer kind of patterns of what's happened, largely by aggregating a lot of data, okay? It's pretty much what it's doing is aggregating data as opposed to doing anything kind of fancy behind the scenes. Next one we have there is around that decomposition tree, which I think at the current version of Power BI Desktop is a feature you need to turn on. We'll have a look at that as well. And that is very much getting into breaking down, okay, well, you know, a nice kind of visual really of what's kind of happened. Again, essentially it's just aggregations, right? There's no kind of real fancy stuff, there's no model really behind this. We're aggregating stuff and further breaking it down, okay? And again, that stuff needs to be enabled. And we'll have a little look at kind of the Q&A aspect, right? So let's have a little look, okay? Right. So what stuff have we got? Okay, my mouse went back. Awesome. Great, okay, so I'm in Power BI Desktop, right? This is our kind of version using AdventureWorks. We've taken the base kind of data warehouse, so the fact dimensional structure of AdventureWorks 2017, or whichever one is the latest AdventureWorks. And then we have supplemented it with some additional data as well. So we've taken some Amazon reviews, which essentially relate to bikes. So if you've not used AdventureWorks before, it's basically a fictitious company that focuses around bike sales, okay? So we've taken some Amazon sales, so some Amazon reviews about bikes. I did take the whole data set and we were looking through it this morning. It's from Amazon US. And the sports element was very gun heavy. So I've taken all the gun aspects out of it and made it related to bikes. There was a lot of Glocks in there. And I was going to go, it was a little bit concerning for the audience tonight. So I thought, right, we'll focus it on bikes, yeah? So it's just bike sentiment today. If you download and you, I've got all the stuff that I can share with you. If you follow it through, there'll be an awful lot of gun data in there as you filter it out. Who knows what? Right, so you've got, here we've got, again, this is kind of our AdventureWorks one, our fictitious company there. We have a little logo there with some stickers if you're interested. And what we really have here is, you know, we've got our kind of model, again, you know, very similar. We've got a kind of fact dimensional model, right, where we're looking at a central kind of fact sales, a product, and we have a product hierarchy based off that, okay? And the first thing we have in here is really this kind of key influences section, which is looking at, you know, what went into a particular sale. So here we're looking at, you know, our total sales and what really went into it, which is kind of suggesting, you know, when you had a particular product here, again, this data is very generated, so it may not actually mirror any kind of reality, but it gives you the idea. When we see these particular products, and if I chop this out for different things, we can see what really went into that to give it a good impact, right? So you have that kind of stuff available. Now, again, if you're new to Power BI, some of the next kind of settings are available under the options and will need to be turned on. They are experimental features. So you need to come down to preview features and click some of this stuff on, right? So we are going to be looking at the AI Insights browser, and we're also going to be looking at the decomposition tree. So they both need to be turned on. We'll also go through very briefly how you actually get the AI functionality to work, because you have to do some admin stuff to get it working. Well, you can have that there, right? So our decomposition tree looks a little bit like this. So down on one side, I've just got a visual there, basically looking at the sales amount by my English month name. Now what this decomposition tree does, again, this is classed as an AI feature, but really it's just doing some aggregations here, is gives you the ability to kind of drill down in a nice visual way, right? So you can kind of click on here and expand and say, well, what I'm interested in looking at here is I'm looking at the high value maybe for my English product category. Okay, and that's going to expand out and show me that, okay, well, for my sales amount, you know, it's a bike company, I did a lot of bike sales, yeah? Or maybe I'll go my subcategory, and I can start kind of drilling through and work out, you know, where I really was focusing my sales. And again, okay, that's quite just a lot of interesting aggregations, and much like all the other visuals, right, they're very context aware. That does give you, out of the box, some quite interesting analysis into what is happening. And certainly gives you interesting analysis into kind of what are the key reasons why something is happening. Because those key reasons are something that we really want to know when we're trying to build out a machine learning model, right? That's that kind of EDA phase. This stuff for an EDA perspective is fantastic, okay? Understanding what goes into it and trying to see, okay, well, where there's massive bias, or where we're trying to produce something, that's going to give us a real good indication. So let's say what I'm trying to do potentially is create some kind of recommendation engine where I'm looking to try and increase the amount of cross-sale with accessories. What you can certainly see here is we have a huge class imbalance, yeah? We've got a massive class imbalance between the amount of bikes sold compared to accessories. Potentially, if I'm trying to classify or work out a way in which accessories can be uplifted, I potentially have a problematic data set here that I need to try and increase and oversample the number of accessories I have in comparison to bikes potentially, right? Cool stuff. And then the last one, which I'm sure everyone's seen a lot of times before, is that we have that kind of Q&A aspect. And now the Q&A aspect, yes, it does use an element of machine learning. So it does use natural language processing to try to understand the kind of requests that you have, but ultimately it's not doing any kind of machine learning on your data, right? But you can say things like, what was the average order quantity, and get those kind of numbers back and start typing interesting things in here, maybe compare the extended amount versus another amount, and you get that kind of look and feel, but now that's all kind of baked in, all nicey, right? So those kind of aspects are very much aimed at the end user as opposed to somebody, that kind of citizen data scientist role, yeah? So what do we have for that kind of role? I don't know why I swapped back to slides. I have one slide which says this, right? Text analytics. Okay, so typically a very common thing. Now it was mentioned in the first talk, by the first Tom, talking about sentiment data wasn't quite used in there, but would factor in largely into looking at how the kind of political climate has changed, etc. So a very common thing, a very common use case for that is typically looking at enriching your base data with social data, such as Twitter trends and those kind of things, to understand and to largely influence, it's a very good indicator of what's going to happen. So we want to have a look at some of those functionalities. So how we go about in sort of basically baking in text analytics, so sentiment analysis, understanding if what somebody is saying is positive or negative or very neutral. Also looking at, okay, what are the kind of key players? What's really happening in the context here? A lot of kind of named entity recognition. So pulling out things like people, places, the kind of crux of what somebody is saying, pulling out that kind of stuff as well. So now we can have a little look at how we would do this in Power BI. If we see how we're doing for time, but we can have a look at how we'd go about building this out in something else. So I have examples in NLTK, which is a natural language toolkit for Python. It's one approach to doing a lot of kind of text-based stuff. There are a number of alternatives, Spacey, which is a bit better than NLTK. NLTK is a bit old hat now, but it's certainly there. And we'll have a look at sentiment in Power BI. So have a look at how it works from a non-Power BI basis, and then we'll hop back into Power BI, okay? So I'm running a tool. Who's familiar with notebooks, as into kind of Jupyter notebooks? Okay, and a number of hands. So I'm running a variant of Jupyter notebooks known as Jupyter Lab. And Jupyter Lab is a way of basically grouping a whole load of notebooks. What a notebook is a kind of interspliced, let's zoom that one in a little bit, interspliced kind of bit of code and a bit of markdown. And that bit of code and markdown really kind of just demonstrates what's kind of happening and gives you that ability to create quite engaging stories. Do a bit of code, bit of text of what I'm doing, why I'm doing that, bit more, right? I won't go through this, so these are all available to download. I will say as well that this is one I nicked off the internet, this is not mine, so I take no credit for it. And what it's going to do is take you through a whole load of things, so basically just a very kind of hello world of NLTK, okay? So the first kind of things that we're looking at here is really importing a couple of libraries. Again, this is Python, okay? So importing our libraries, importing our data. Typically, if we're going to work with any kind of data inside Python, we're going to be using pandas, okay? This is kind of pandas syntax. I shall gloss over a large amount of it until we get to the core bits, right? So here, okay, we have got, once it's zoomed in, we get multiple things. So we've got our train and test data, yeah? We saw that in those initial slides where we're looking to do some kind of supervised learning. I take my data and I split one part off for training and I put one part off for testing, yeah? That's pretty much what's happening here. and my test size is 0.1. So essentially I'm just saying take 90% for training and 10% for testing. Those kind of ratios are up to you and very dependent on the data that you have. Maybe a little bit on the low side, but that's okay. Then what we're looking to do there is remove neutral sentiment. Okay, we don't like fence sitters. When we do this stuff, we don't like the people in the middle. If this is movie reviews, we like the people who are very kind of binary, right? Did you love it or did you hate it? If you're like, it was okay, those guys just ruin any kind of model we're looking at. We're going, either you hate it or you love it, right? Smart mind. So we're having a look here, we're getting rid of any neutral sentiment. And then what we're doing here is basically going to grab all of our positive sentiment, all of our negative sentiment. And the first thing that we can do here is start having a look, right? Understand what data we're working with. Build out a word cloud. I'm a big fan of word clouds, but you can get the idea. What's the biggest thing that's in bike sales, right? Bike. But when we're doing sentiment analysis, we're looking for quite emotive language. Now this is reviews that say scraped from Amazon, so you've got a kind of 5-star rating here. When we did this earlier, it said knife, massive letters, and I was like, right, that's definitely not what we want to be doing, right? Bike is better. Okay, so we have bike. But you can see there's a bit of emotive language. We have good coming out very large there. So typically these kind of words that are very emotive are going to bubble up to the top, right? Then we have things like, let's have a quick look at the negative. So negative, right, it looks very kind of similar, right? We have bike again. Okay, it's a bike data set. But we'll probably start seeing things like there was a hole, flat, the kind of negative aspects of what we're looking at. And then we can take that very much through through NLTK to do sentiment. Now there are very different ways that we can look at when we're ever looking at some kind of sentiment-based model. We can look at sort of trying to optimize for sentiment, so try and understand the words which are positive or negative, or ultimately we can look at our kind of corpus of text, which is typically what we just call the words, our corpus of text, and try to optimize for something, okay? Two kind of different approaches. Here we're just going to use a pre-built sentiment model, and we're just going to use that, okay? There are problems with that, but we'll come back to that in a moment. So here what I'm doing is ultimately just iterating over and trying to work out every single word. So what I want to do is take that review and I want to break it down into individual words, into individual grams, or sometimes we look at pairs of words or tries of words or wider, okay? So it may be that you say, like, this is really good, like really good together is one kind of positive thing. Really and good on their own could be taken out of context. Things like sarcasm on individual words is typically missed. As you increase the number of words into essentially bigrams and trigrams, things like sarcasm at least start to come through. Okay? So we're going to do that, break it all down, right? You can see there's a lot of work going into this, yeah? So it's basically what I'm trying to show you. There's a lot of work to do this, okay? I'm doing some stuff, more stuff here, creating a couple of functions to understand that. I'm going to produce another word cloud of the key kind of features that we're looking at. So well seems to be bubbling up there, bike, update. Alright, and we're taking in a model, okay? So this is our generic kind of model here. We're taking in a naive Bayes classifier, so it uses a Bayesian approach to classification. Bayesian basically is just based on looking at the prior knowledge of what you have. So we're taking here NLTK, a Bayesian classifier, and then we're going to train it with the data that we have there. So we're taking that data in, training a model, ultimately to get that out. And we're going to run this live. It takes about 25 minutes to train that, even just on, I think I have something like 1,000 reviews. And then ultimately, that's going to give us our model that we can start working with. Now I could take this model out, I could persist it somewhere and productionize it. That hopefully gives you an idea that there's a lot of work that goes into that. So how would we do that in Power BI, right? How would we get a very kind of similar approach? So what we've got is the exact same data. We have things like, here I think I've looked at what we got, an order of bad reviews to good reviews. So the sensor did not work, period, right? I'm angry, right? I've written period. I've installed at least 6 other bike computers, all worked after adjustment. This one would not sense the wheel motion, void, right? This guy's annoyed, okay? So if there's some fairly emotive language, there's capitalization in there. There's nothing like, I hate this bike component, you know. And there's some other stuff, right? Okay, so here, you take this one, right? This is where things like, we're looking for things like emotive language. This is a 2-star review. Good news, good, right? Positive sentiment. Good news, solid design. Bad news, not so far, easy to assemble. Nice design. So there's a mixed amount of emotive language in here, which makes these things quite difficult, yeah? So, how do we go about doing this? So I've imported this data already. I'll say there's a script for this if you're interested. But the options I have available to me now, if I go down to edit my query, is I can come in to add a new column. And over here, right, I've got a couple of new options, yeah? I've got these kind of AI insights. So I've got the text analytics that we're going to look at now, looking to try and append a new column on. I've got vision, which is ultimately going to go away to a cognitive service that I have already pre-built. Or I have an Azure machine learning model, again, something pre-built, right? So we'll have a quick look at text analytics, okay? Add this one in. And the first thing that you may notice is right down here in the bottom, it's going to ask me, what premium capacity are you going to use? So when we look at all of these, right, these are premium capacity only features, okay? Which I imagine is going to piss off a lot of people because generally premium only things do, right? So this is very much aimed at the enterprise customer with premium capacity, okay? Or you can very much do what we've done. Yes?
Is this premium capacity for workspaces or?
Premium capacity in general, so I have it associated to a workspace, but yes, it needs to be where you need to basically have a premium capacity or an embedded capacity. It works both in the same way. This one's actually using embedded because you have to talk to a sales rep to get a premium capacity. I'm not doing that, right? I'm just going to use the embedded one, okay? So yeah, so I have that hooked up there. That is all set up in my Azure tenancy. And now that gives me the ability to actually go and start using that. So then you've got these couple of things up here, yeah? I can detect language. So if you've got multi-language appearing in your data, again, going to be very common in the kind of text models that we're looking to do. It's very common that you're going to have multi-language in an English-based system or in a non-English-based system. So understanding what text and what language is in there first to maybe treat that differently or throw that text away, then that's going to be important. Or we can come in here and just choose something like scoring our sentiment or extracting those kind of key phrases, right? Gives you this kind of thing here. How would you like to score your sentiment? You can come down here and choose a particular column that you want. Don't do what I did and just write the word review text, because the sentiment for review text is very emotive. So, you know, actually pick the column, right? So come in and select that one and then hit OK. And what that's going to go away and do is then go and grab the sentiment scores, okay? So what we're looking at here is where we had something which was quite emotive. So somebody really liked that, they gave it 5 stars, right? This has come back and said we've got pretty much a 92% positive model, okay? We think, based on the sentiment we see there, that is 92%. We can see down here, you know, that person's given it a 2, it's come out as a roughly about a 5, that's fairly aligned as well, right? So it's kind of doing a lot of good. It's certainly going to miss a lot of nuance and a lot of bias in here, but it's a good enough kind of approach for what I'm looking at. Now, you can see things here, right? 5, oh, I love it. And they got a 70%. Now, if what I was trying to model wasn't necessarily well fit to natural language, then I'd probably have a problem, okay? So where you may have a particular domain that isn't necessarily well trained with natural language. So the way that these models are basically built is that they typically scrape huge amounts of corpus of text. That could be from Twitter or from some kind of social media where there's lots of text, and they use that to train with. So if you work in a different domain, let's say medical or something which is a bit more niche that doesn't lend itself well to natural language, then this stuff is just going to not work for you, and you need to look at a different way of doing this, which would go back to the first example of doing this manually, right? So where you have a different domain, it can be very problematic. But for what we want to do, I mean, that's pretty good, right? That's not too bad. We can come in and add something else. We could say that we actually want to add on our, extract some key phrases from here. Again, stick our review text on. Hit OK, and that's going to go away. It's going to take a little bit longer. It's a bit more work to sort of happen there. But we can see, right, key things coming through here. that it related to maybe different companies. Maybe that was the reason something was negative because it came from the wrong company. There was Spare Hands company. It gives you some idea, right, of kind of the key crux of why maybe somebody's review was positive or negative. And it gives you that additional kind of depth of understanding that you may not have very quickly without really having to do a great deal of work, right? Cool. So that's one thing. Say we've got vision, we have Azure machine learning as well if we had some kind of pre-built models. Now, let's hop back. Oh, I didn't talk about how you enable it, right? Because this stuff's a bit annoying to get set up. So, in order to get this stuff set up, you need to go in. It's an admin kind of setup. Come down, go to the admin portal, and again, you need to have some kind of premium capacity. So it's very much going to be, over here, looking at the capacity settings. Zoom in a little bit, a bit easier to see. We've got our kind of capacity settings. I don't have any premium, but I do have Power BI embedded, so it does work on an embedded SKU as well. Don't remember which one, certainly on the base one, it might be third premium SKU, A3 there. Gives you an idea, right? Then you need to come in and configure this one. Under management, what you've got is a couple of advanced options. Workloads. So you will need to turn that guy on, right? You need to turn on that you want to be supporting AI workloads, and the other thing that needs to be enabled as well is data flows, okay? With those two things, the rest of the stuff will work. So premium, data flows, the AI section on, and the rest of it, that stuff will work, okay? Cool. So, moving on to the fun stuff, right? So AutoML. So this is where the democratization of machine learning really comes into full force, okay? So with sentiment, we're looking at taking somebody's pre-trained model. With AutoML, what we're looking to do is basically take a whole load of different approaches and just try them all, right? Just try everything and see what comes out with the best one. That has pros and it certainly has cons, and we'll talk about those, okay? So this is the kind of thing that maybe I do, right? This is what we do as data scientists. I take my data, I clean my data again. I've done that kind of EDA phase and potentially I've iterated a number of times, yeah? And then maybe I'll go and I pluck some kind of model. I'm trying to do some kind of classification here, okay? I take something like a decision tree, which is essentially a way of kind of doing what expert systems did, but in an inferred way. Then what I do is I show it my new data and I get my prediction, yeah? I've gone through and I've trained it. I've got, I'm okay with it. It's given me an okay level of accuracy, but I'm going to try something else, yeah? So I try maybe something like some kind of logistic regression, okay? Try some new data, get a prediction. Maybe I'm like, actually I want to try something else. I try a neural network. And with each one of these, it's not like there's just one type of decision tree. There are hundreds of different approaches. Hundreds from people like Microsoft Research, from Anaconda, from Google. There are a whole load of different approaches that you can take, yeah? Same with logistic regression, and then, times 1,000,000 for a neural network approach, okay? So going through and doing this phase is a lot of fun, right? This is typically, this kind of phase is like 80% of machine learning, and this bit's like 20%, but that's a lot of fun. But it's very time consuming. So what if you could actually just say, well, I'll give you my data, you do this stuff for me, right? That's kind of what AutoML is looking to do, okay? Until you get down to the model that you are happy with. So this is what we're going to get towards, right? We're going to look to show it some data, again, about bikes. We're going to look here at the San Francisco bike data, which looks at bike rentals, okay? What we're going to do is going to say, right, you're going to need to optimize for trying to predict how many bikes I need to have in any particular location on any particular day, based on the data that we show you. So things like the humidity on a particular day, the time of the day, if it's a weekend, if it's a holiday, all of these kind of stuff, right? Some kind of key indicators. And then we're going to say, just do your stuff. Just try a whole load of different models until we get something we're happy with. We're going to maybe run for 25 different iterations. And what you kind of get down here is this view of our maximum model quality, and we can kind of gauge that and pull out a good model, okay? We'll have a look at that as our last example, and then we will finish for questions. Right, so all of this stuff is going to happen through the portal, okay? So what I'm going to do is, this stuff is all enabled through data flows. It has to start and end basically. Its journey is a data flow, okay? We're taking a data flow, we are enriching it with a machine learning model, and then ultimately that's going to produce us another data flow that we can work with, okay? So I'm going to come in here, I'm going to go into my particular workspace, which I've got my Advancing Adventure Works, and come in here and maybe create a new data flow, okay? So I'm going to create one, I want to create a new data flow, and you've got the kind of normal options that you have with data flow, so from finding a new entity, importing, maybe going from some kind of common data model as well. So we're going to go with defining a new entity, and maybe go to blob storage, and we can pass in the name of our blob account and the key as well. Now, to save time, I will just kind of, no, let's do it, let's grab it, right. So what I've got here is this is Azure Storage Explorer. So it's called DataFL, and then if you pulled my key in for me, good old LastPass, thank you LastPass. And I can see here that I've got a file here called bikes, right? And the data that I've got here is there's two different files. The ones that I want to work with is our hourly data here. So I want the binary from that hourly data. I can just hit into here, let's go transform. Let's say what I want is the binary data for the hour. And I'm going to use this as my base data, okay? So hopefully when this loads, what we'll see is we have the particular day, the season, the year, if it was a holiday, and the column that we are trying to optimize for is this one at the end, okay? Which is the count. So we're going to go for that 16, 40, 32, okay? That's what we're training towards, all right? So let's just say I'd like to save this one. I'm going to save this as Power BI likes. Okay. Save and close. And now this is a data flow. Now I can start enriching it and start working with it from an AutoML perspective, okay? There you go. So while that one is saving, I'll show you one that I made earlier, right? True Blue Peter style. So I've imported this one here. We've got those kind of fields that we've seen, and we've also got down there our count, okay? It's inferred the data types and all that good stuff. Now over here, I've got this little brain, right? This little guy here is, whoops, that's a good one. And that little guy is going to be essentially what we use to start triggering our AutoML. So I can click into here. I can say I want to add a new machine learning model. And now this is going to go through and it's going to say, okay, well, what are you trying to do? Your entity is bikes. What's your outcome field? Now, outcome field is a really weird name, right? That's not something as a data scientist we would typically see. We're typically optimizing for a label that basically just means label, okay? So we've got outcome field. What do we want to choose? We want to choose the count, right? That's what we're going to optimize for. We'll go next, infer that, okay? It's going to infer that what we're trying to look at is numerical. As it's numerical, we're going to go regression, yeah? If it wasn't, then we would get a binary classification suggestion or a multi-class classification suggestion, and we can choose which we want. Say my regression, hit next. And then, this is the interesting thing, okay? This is what we start seeing. Start giving you an indication of how well correlated our values are against the data that we have. So now what this is trying to show you is it doesn't think that any of these are good indicators. All right. So if you were to take this at face value and you were to say, right, okay, this is good, I'm going to go with what it suggests. I'm going to go with casual and registered. Basically, those two add up to the label we're trying to predict. That's going to create you an amazing model at predicting just rubbish, right? Because that's the label we're trying to work with. We don't want to select those defaults. Those defaults are garbage, okay? But we want to have a look at some of these. Low correlation doesn't necessarily indicate a problem. Low correlation typically indicates that maybe there's some nuance in our data that maybe we need to fix. So there are typically things that you want to remove. You certainly want to remove high cardinality, so where you've got lots and lots of different rows. So let's say you had your customer name in there. It's very difficult to work with that. We don't want to work with that. So things like predicting fraud. Personally, I know that people named Brian commit a lot of fraud, but I'm not going to put that into my model. Okay, sorry for the brand. So stuff like that we need to remove. So high cardinality and high correlation as well. So now these will eventually flag up as high correlation because they are very highly correlated and they should be removed. The stuff's available in demos already. But let's clear up some of this. Let's pull in some things that we think would work, right? Season, maybe the date, maybe the year, hour. Hour's probably a good one, right? Bike rentals, things like London bikes. People are going to rent bikes a lot kind of before work as they're cycling to work. Maybe it's going to spike a little bit after during lunch, go down again, spike in the evening, and then kind of peter off overnight, right? So hour is probably actually going to be a very good predictor for us. Holiday, weekday, maybe it's a working day. And things like temperature, yeah? Temperature is probably also going to be very highly correlated. If it's a nice sunny day, more bikes. If it's a rainy day, less bikes, right? And then we certainly don't want to include the column that we're trying to optimize for our label, because if you do, you make an incredible model. Again, that is just garbage, right? Okay. And then you get these options. So how long would you like to train for? If you have a lot of data, then you can say, right, what I want to do is I want to run this a lot of times. I want to run over a lot of iterations. And how much of your compute against your premium capacity and stuff do you actually want to use? So you can turn this up. You can say, at the moment, it's a train for 120 minutes, 5 minutes, or all the way up to 360. Yes?
On the previous, what about intercorrelation between your new requests you have is intercorrelated about more? There's no indication. Right?
No indication. Yeah. So stuff like
that. Handpicked.
Yes. Yeah. So that would be lovely if there was an obvious pattern appearing, that things kind of co-located. And I'm sure, right, these kind of things that are typically done will kind of more than likely migrate into the product at some point in the future. Who knows? But that stuff, would be nice to see, right? So here we've got a really small data set, right? So I can set that to 360 minutes. It's going to train really quick because there's no real data here, okay? So we'll just kind of leave it there. We give it a name. Call it the London Exeter. And we'll just set it to the bare minimum, okay? Let's set it somewhere there, right? 33 minutes, okay? And I can hit save and train. And now what it's going to go away and do is it's going to start trying to apply a whole load of different models for me. So now if I have a look into my bike data by hour, which is the one that we were looking at just then, what I'll have is over here I've got entities and I've got machine learning models. And now I'll have this one down here, London User Group, which is currently training, right? This is going through and trying lots of different models and it's trying to work out, and it's trying to optimize for something. So now when we look at a regression model, there are lots of different metrics that we can ultimately try to optimize for. These are called loss metrics, things like mean squared error, root mean squared error. They are generalizations as to how well our model is performing. The things that we need to know. You don't have any option to set that stuff, okay? You don't have any option to do any kind of parameter tuning either. You kind of get what's given to you and you have to live with it. Let's see if that guy's finished. If not, we will have a look at the one I made earlier, right? Of course. Let's go all the way back. Thank you. Machine learning models. He's still going. So I've done the exact same thing here already. And one of the things that you get is you get a training report. And this is quite handy, okay? This is going to show you a bit of an indication of what's happened. And we can have a look at our model that's being built. So that was the visual we were looking at on the slide. When it eventually loads, it'll show you some kind of analysis. And you get this baked in, right? So what you can see there is the final model that was trained for was this pre-fitted soft voting regressor, right? No idea what that thing does, okay? And it gives you this kind of stuff, right? So we trained with 13,000 rows, we sampled of these ones, and then this guy down here gives you an indication of what else kind of worked well, right? So here we had a light gradient boosted model, which is also a regressor, right? And you can see there the kind of hyperparameters that have gone into this. So each one of those there, number of bins, maximum depth, those are hyperparameters, right? So it gives you a good indication of kind of what's happening. And then if you want to, you can come up here and say, right, the best model is that one. It's come back and it's given me a degree of accuracy. Come down here and have a little look. And we can see which features we use, the number of models that were created. And let's have a look at our model performance as well. Well, we can see again, right, we're making a regressor here, right? So we're looking at kind of plotting one thing against another. And we can see this has roughly come back and said it's 81% accurate, okay? So 81% accurate on regression model is an odd thing to kind of see. Ideally, what we're looking at is kind of the range of loss. So typically to say, well, when we're forecasting, when we're recommending that there's going to be so many bike sales, we're wrong on average by X amount of sales, right? That's a good indicator. Accuracy kind of gives you a similar thing here. We're abstracting that away a little bit to make it a bit easier to understand. And we can say I want to see some top predictors. So temperature and average temperature were key top predictors, right? They were the one thing that really bubbled up to the top that was most important. When it's hot, more bikes get rented, yeah? And the other thing was, the other kind of top predictor was when the time is 17, so when it's the 17th hour, 5 o'clock, when people are trying to cycle home, that's when there's also a larger amount, right? And this is some interesting insights that come out, again, all out of the box, yeah? Then if you want to, you can say, I would like to apply this model, and then you can choose what you want to do with it, right? So how do you want to apply it? I'd like to apply this to a data flow that I have. Maybe that is a separate data flow. Ideally, that is new data this has never seen. Now, I don't have the new data, I've just got the same data. So I'm going to apply it to the same data I have. Don't apply it to the same data you have, because it's going to look really good, right? When it looks really good, it's because it's basically fitting to data it's already seen. It's scoring data it's seen, which can very quickly make you look like you have a good model, but can very quickly indicate overfitting, where your model is too closely fit to the data it's seen. When you show it new data, it just gives you garbage, right? But I'm going to do that because that's what we have. I can just hit save and apply that data on. It's going to say you can't do it because I've done it already, but it would work for you. And then you can just import that into maybe another report and start having a look, right? So what I have here is I've produced my model, and my dark blue one there is my prediction, and my other one is my actual, and you can see that across the board we're roughly not too bad, right? We're a little bit over on our prediction, but not by much. Again, those numbers have been blown out a little bit there. We can see things like down here, that where we actually start seeing it, we can see that our numbers are generally quite bad at this point, right? 150,000 was our actual prediction, 215,000. Okay, so that's quite a significant amount of difference. So across when we look at year and quarter and things like that, it's massively out. However, when we look at things like time, etc., they are very similar, right? So there's certainly a problem here, and it's a problem that we can certainly fix as well by cleaning the data and trying to remove some kind of nuance and bias, all right? So interesting stuff, but a lot of this is just to really kind of show you to be cautious about what you're doing. Some of these defaults are not the right defaults to accept, and some of the things that it will recommend and some of the ways and the approaches it will take are certainly not optimized for what you would actually want to do. But if you're doing the challenge, right, if you're going to do next month's Power BI dashboard challenge, stick some of this stuff in, right? See if you can help enrich the data that you have and squeeze that extra bit of analysis out of it, yeah? That's what it's going to be good for. Okay, so, right. So does it meet the need of a data scientist? It's probably not, right? Because we're focusing down here. For this area, this kind of role, spot on, right? This is fantastic, certainly helps. But again, without that kind of existing prior knowledge, we can go wrong very quickly and produce something which gives the wrong kind of impression, the wrong kind of analytics. You're better off potentially looking at some of these things for different types of models, especially if you're looking at something which has super low latency, then certainly Power BI is not going to be the right thing for you, right? But that's one kind of approach that we have. So, for our advanced analytics users, no tech kind of functionality is really needed. It's very limited, but it certainly gets you started, right? Good things to give end users, and they can feel empowered with that analytics. And from that kind of C-level, they're like, yeah, look, right, we've got AI in our business. You're like, yeah, okay, AI sells, right? So at least they can do that, they're happy, and kind of see that nice fluffy stuff. Then if you want to get a bit more advanced, you certainly got that AutoML, great for looking at kind of pre-built models, some configuration required, some kind of optimization really to get the best out of it and really to understand it. And ultimately where you need that real grunt and real kind of stuff that fits to your domain, especially if you don't have a domain that fits neatly to very pre-trained models, then that's when you go full-blown, right? maybe a 0ml. And the key to remember with that is when you do that, if you're going for a 0ml, then that stuff can also just kind of neatly link back in, should that be the way that you want to work, right? So yeah, I'd say that data science is very much being democratized. There are ways in which we can do this stuff and get accelerated in what we're trying to do. So Power BI does offer that report developer that ability to do it, but think critically about what you're doing, yeah? Think about the approaches that are being applied and just think like, am I potentially overfitting? Am I potentially causing something that isn't going to actually work very well into the future, yeah? So all my details are here, cards are there, stickers if you want your AdventureWorks ones, they're available as well, right? So I'm sticking around. If you have any questions, by all means, fire them at me. If not, then thank you very much. Questions?
I was wondering, the AutoML,
yeah.
Can you actually do any language processing?
Can you do? No, you can't. Well, no. So if you were to do some pre-work to it, you definitely could do language processing with it, okay? But you'd have to do an amount of work up front, which wouldn't be something that natively would fit inside Power BI. So you would have to try and do that either with a kind of custom R script or a PowerShell script and do it that way. So essentially what you'd have to do is tokenize your values with something like NLTK or Spacey, and then build out basically a vocabulary model. And then with that vocabulary model, so basically you say, I love this product, okay? You encode each one of those words as a number. I is going to be 1, etc. And you model like that. So your words get turned into numbers. Because whenever we're looking at machine learning, all right, text just doesn't work for machine learning. Even if we look at sentiment models, they're not processing text, they're converting those textual representations into numbers because we're doing lots of linear algebra, okay? So if you wanted to do your own stuff in AutoML, yes, you could do, but there's a lot of work up front to reshape it to work in that way.
Possibly any more might be easier in Python.
100% it would be easier, right? Because you've done a whole load of work in something that works very neatly, and then you're going to be like, going to take all this good work and then put it through that. There are, when we look at this stuff, right, this is nothing new, okay? This is an enterprise feature that you can do for free, okay? There are frameworks such as Teapot, which is just the best name anyway, which is a way of doing AutoML. There are other tools on the market. There are Data Robot, there is Hyperdot for things like Spark as well. All the stuff we've looked at, you can do in a different way, okay? So you can do all that stuff, it's just they are manifesting it in Power BI to make it that little bit simpler for you. Yes?
Is AutoML hard to explain because it's like a black box? So you can't kind of explain to your customer why it reached that result?
Yes and no. So you'll be able to see what kind of parameters have gone into it, but yes, you're not going to be able to get the kind of explainability that you would out of, say, if you, so shallow machine learning is typically a lot easier to interpret compared to something like deep learning. And again, this is very much on the shallow side. So you're getting a model out the back that is that degree of interpretability. So through that kind of dashboard, you can see what went into it. And one thing that we didn't look at here is what you can see off the back is you get the reasons why a prediction was made, okay? So you'll see here, this is what comes back out of our regressor explanation. So you can see that our prediction was 11,000 and it predicted, wrong one, that's the model index. Our prediction, it was 12, and we predicted we need minus 37 bikes. Remove all the bikes, right? That's not gonna work for us. But we can see why, okay? So that's your interpretability, that's your explanation, okay? So you can see it from that. But it's per row. There's no kind of aggregating this up without doing a little bit of work. But you could do it, right? And that gives you that explainability.
Have you ever run them against each other, AutoML versus custom, to see how well AutoML scored in terms of error? So
what I would always say is AutoML is a great way to understand which models you eliminate straight off the bat, right? So you look at it, you take your data, maybe you don't do a great deal of engineering on it, and you say, right, just go nuts, right? I'll go to lunch, I'll leave this training overnight, and I'll see which things I should just definitely not even bother looking at. So what you might have seen in some of the predictions that came out in here were very kind of coin toss. So lots of kind of 40, 50% models, you know, a 0.4 score. A 0.4 score, you know, worse obviously than a coin toss. Ultimately, we can look to try and flip some of that stuff around. But it's a great way to throw away which models you shouldn't do, Doing that in Power BI, probably not the right place to do it, but it could help you, right? You could do that, you could understand this, use Power BI to do the AutoML, and then build something in Azure Machine Learning Services, or you could just use the AutoML in Azure Machine Learning Services, which ultimately is a lot better and is a lot easier to work with and gives you the ability to say, well, I like that model. I know you think this is the best one, but I know that that's a good one, so I'm going to use that one. You can't do that in Power BI, but you could in, say, Azure Machine Learning Services. Cool.
Okay. The Azure Machine Learning option in the AutoML interface, does that connect to any model that you build?
I do not know 100%. I'm going to say no, because I'd imagine it won't do. To what extent it connects to lots of things, I'm not entirely sure. I haven't tried it enough in Anger to give you a definitive answer. Docs say that it works quite well, but not really tried it in Anger a great deal to give you a proper outcome on that domain.
Would that be a way of just actually, rather than kind of trying to productionize your scripts and make them run in it before pre-consumption layer?
Yeah.
Could you just build whatever you wanted to do and trigger the data?
You could do, and there's a trade-off, right? Because what you'd be doing there is every time you ever look at your data, depending on when you're rerunning your data, you're going to be constantly rescoring. And a very batch approach typically is something that you don't necessarily want to do that frequently. It may be something you want to do nightly or weekly and then expose through your model. So you'd be better off using a kind of different service, persisting that in, maybe back into a database or a lake or wherever you persist your data, and then bringing that back into your model in a more kind of structured ETL pipeline. For me, that's my preferred approach. But yes, you certainly could do. If your model's changed really frequently, right? If you had a really high kind of turnover and you needed that, maybe that other approach would be better.
So when you do Azure ML, that option, is that restoring it every time, or is it just running?
Every time you re-put in your data, it's going to rescore.
Is there not an option to just run it? So you already have the model, it's trained, you know what it needs to do, and it just takes it and puts it out there?
Not at the moment, not by the look of it, no. So at the moment, it looks like it's going to go do that. And most of the stuff, you saw that's low volume, that stuff wasn't too much. When you're looking at large amounts of volume, it's potentially going to have a higher overhead. But then also you can scale that stuff up, right? You can load balance it, stick it inside Kubernetes, scale the crap out of it, right? If you needed it, depending on what you need. Cool, well, pizza is here. So enjoy, as I say, I'm sticking around. If you want to ask me questions.